you're at work, sitting at your desk, and it seems that all is well. You just deployed a minor code change where you added additional unit tests. You glance at your production graphs, and everything looks healthy, so you direct your attention to more urgent work. A few hours later, your phone starts buzzing. Your phone is blowing up. Turns out your recent deploy has caused your service to go haywire. Users are receiving 500 errors, and you have no idea why. You are floored. This was just a simple unit test, and now you're facing a P1 incident. How in the world are you going to fix this? How many of you have ever experienced anything like this? And what did you do to solve it? Maybe you dug into logs, you reran your tests, you crossed your fingers. But what if this wasn't the way it had to be? What if there was another way, a better way, where you would never even get to this point to begin with? My name is Melana Hammel.
And I'm Justin Field.
We are both software engineers at Nike. Nike's e-commerce business is in the billions. So this means that for any given outage or production issue, for one of our consumer-facing services, there's a lot of money on the line. We work on a platform team where we create cloud-native solutions to enable other engineers at Nike and encourage CI/CD best practices. We wanted to reduce the risk for deployments for the engineers that we serve. So our search led us to what we are here today to share with you: use Canary deployments. What are Canary deployments? Well, Canary deployments introduce a code change to a small percentage of your traffic. Where does the term canary come from? Canary in a coal mine. The reference goes back to when miners would bring canaries down into the mines with them. If the canary stopped singing, because it died, the miners knew to get out of the mine because there was a carbon monoxide leak. So canaries are now known as early indicators of potential failure or dangers. And for software deployments, canaries offer a lot of value. They can help catch mistakes or errors that previously would have been deployed straight to production. They offer a way to test new code in production while limiting the blast radius if anything goes wrong. And because Canary deployments can be automated, they save engineers time because engineers don't have to monitor logs or watch charts as often as they used to. So we needed the ability to Canary at Nike. Now, Justin will walk you through our journey to find a Canary solution.
All right, so we knew we wanted a first-class Canary experience for our continuous delivery solution. In that search for a Canary solution, we faced the classic build versus buy scenario. We had an internal solution, but we knew it was going to need major work to get the user experience to be where we wanted it to be. We could spend the time and energy to uplift that internal solution, but because of our belief in open source software and the benefits from cross-company collaboration, we looked into the open source space to see what was going on. Our search led us to Spinnaker's Kayenta. Spinnaker, as you probably know by now, is an open source, multi-cloud, continuous delivery system. Spinnaker is composed of many microservices that work together. One of those microservices is Kayenta. Kayenta is a platform for Canary analysis. It's capable of integrating many metric sources and doing A/B-style statistical testing. We identified it as an industry standard for Canary analysis, having the benefit from the work of data scientists from multiple companies across the industry. This was a great opportunity for us to align on the work of the open source community. So we found ourselves at a third option: collaborate. So we couldn't use the complete Canary experience that Spinnaker offered as a whole. So we just wanted to use Kayenta as a standalone service. Kayenta did almost everything we wanted, and we really liked the user experience that Spinnaker offers for Canary out of the box. So we decided we wanted to extend Kayenta to meet our needs and contribute any of that work upstream so that others could benefit from it too. We were at last year's Spinnaker Summit as attendees, and we had some early conversations with the community about using Kayenta as a standalone service, and we're here a year later presenting. So what did we come here to tell you today? Canary. Use Canary deployments when making changes to production. Make your life easier as a developer. Spend less time manually watching graphs and logs, which are prone to human error. Prevent large-scale production issues. Use Canary deployments. So you can Canary two different ways. You can Canary now with Spinnaker, which has great first-class support out of the box. You can also Canary using Kayenta as a standalone service, which is the process that we helped enable and the process we're going to share with you today. So which path should you take to Canary? Standalone Kayenta or just using the out-of-the-box features with Spinnaker? There's a spectrum of scenarios where it's going to make sense to use Kayenta as a standalone service to where you'd be much better off just using the automated Canary analysis stage in Spinnaker. The first scenario is when you have an organization that is not using or planning to use Spinnaker. This group of people is going to get the most value out of just using Kayenta standalone. The second scenario is where you have adopted Spinnaker, but you're not going to adopt it for all of your frameworks / infrastructure. For example, you're going to use it for virtual machine instances, but you're not going to use it for serverless or containers. This group of people is still going to get a lot of value from using standalone Kayenta. The third scenario is when you're transitioning to Spinnaker and you still have a bunch of legacy deployment processes lying around. So depending on your transition timelines, it could make sense to use standalone Kayenta, but you're probably going to be better off using the Canary features in Spinnaker. The final scenario is where you've gone all in on Spinnaker. In this situation, it's not going to make sense to use standalone Kayenta at all. You're going to be much better off just using the Canary features in Spinnaker pipelines. So let's drill into standalone Kayenta. We're going to talk about three things. Theory, how do Canary deployments work with Kayenta? Implementation, how does one implement Canary analysis with standalone Kayenta for an enterprise? Experience, when theory and implementation is combined, what does this unlock for your users? Let's dive in. Kayenta is a platform for Canary analysis, and it ultimately judges whether a Canary is good or bad. So let's see how a Canary deployment works with Kayenta. Before we can even start to think about Canary deployments, though, we're going to need to be able to define what makes our application healthy and measure and report it. It is important to define metrics, what metrics matter for your service, as this is the foundation for Canary configuration that Kayenta uses to judge the health of Canaries. When creating Canary configuration, the Spinnaker Canary guide recommends that you use 3 out of 4 of the golden signals of monitoring. Those signals are saturation. These group of metrics inform how full your service is. They are metrics such as CPU, memory, and disk usage. Then you have latency. These groups of metrics inform you how long your service is taking to fulfill requests. And then you have errors. These tell you at the rate at which requests are failing. Okay, now we can start thinking about Canary deployments. Let's take a look at the state of our application before a Canary deployment. We have traffic being routed to our production server group. All the instances in that production server group are reporting their metrics to some metric store, whether that's SignalFx, New Relic, or Prometheus. Phase 1 is where we deploy the baseline and Canary groups. This is where we let a small percentage of traffic flow to our experiment and see if our little Canary lives or dies. But what does this mean? What is the baseline in Canary? The baseline is a fresh version of what is currently deployed to production. This can be a baked AMI or a Docker image. It's some sort of deployable artifact. We do this to eliminate cold boot issues such as cache warming and help make metrics between the baseline and Canary equivalent. Whereas the Canary is the new deployable artifact. So as you can see above here, the baseline and the production is running the old version, 1.2.1, and then when we do our Canary, we're going to launch 1.3.0. In this situation, we have multiple server groups deployed with the same application version running, so we can't just use the version to differentiate between the production group and the baseline. We need to make sure we're sending metadata with our metrics. That includes a unique ID for each server group. This is so that the metrics for the baseline can be queried separately from the current production. The baseline and the Canary also need to receive the same amount of traffic for certain types of metrics to be equivalent. Metrics such as error counts would be meaningless in scenarios where the volume of requests are different for the Canary and the baseline. You could maybe convert these metrics to rates, but then saturation style metrics, CPU usage, memory usage, they start to get weird when you make them rates as well. So let's take a look at two routing strategies. The first routing strategy is size-based routing. We sometimes refer to this as coarse-grained routing, since the weights are controlled by instance counts. This strategy is the most common one we've come across because it's the simplest. This strategy is simply to round-robin requests through some sort of load balancer or on the client in the case of service discovery. So as you can see in this diagram, 80% of the incoming traffic is going to be flowing through the production server group. This is because it has 8 out of 10 of the instances. And then we have one instance for the Canary and one instance for the baseline, so those are going to get 10% of the traffic each. The second option is going to be some sort of fine-grained weighted routing. So this strategy relies on something smarter than round robining, and it's going to allow you to set specific percentages to your Canary and your baseline. So Amazon Web Services API Gateway has features around this, for example, but this involves a more complicated infrastructure setup in the deployment process. All right, now phase 2. We have our infrastructure set up. We've deployed a baseline and Canary. The baseline and Canary are receiving equal amounts of traffic. The baseline and Canary are reporting their metrics with metadata that allow for their metrics to be queried independently. We can actually start the Canary phase of the deployment process now. The first step of this phase is to wait and allow traffic to flow through the system and to let metrics flow through the system as well. After some amount of time, we can query the metric source for the baseline and Canary and do a statistical comparison to see if the Canary metrics has changed for the worse. If the metrics for the Canary are bad, we can fail fast and exit the Canary analysis phase with a fail status. However, if the metrics for the Canary are within a configurable threshold, we can continue and do another wait and judge cycle and repeat this process for n intervals over some lifetime. At the end of this process, we make one last judgment and produce a pass or fail result. This can then be reacted downstream, whether that's automatically rolling forward with your new version, your new application version, or rolling back, or even stopping and allowing for some sort of manual user decision. So let's recap how Canary deployments work in Kayenta. We instrument our app to report the golden signals so we could use those later to judge the health of a Canary. We deploy the baseline and Canary alongside the existing production group. We do Canary analysis over some lifetime and perform multiple judgments, failing fast if we need to. And then finally, we get an aggregated judgment result and we react to the results. All right, Melana, all this theory is great, but how do you get it to work?
Well, it is just a simple matter of programming. Let's talk about what you can use to Canary with Standalone Kayenta, and then what you will have to build. So what can you use in terms of open source software to Canary? We built Referee, an open source UI for viewing reports and using developer productivity tools. Cool logo, we know. We had realized we needed an additional layer for our customers to be able to process the results from Kayenta. We tried to get Deck, Spinnaker's UI, working for just Kayenta, but it is too tightly coupled with this complete Spinnaker solution. So we built our own UI that's just for Kayenta. Throughout the whole process, we partnered with members of the Spinnaker UI community and engaged and collaborated on designs and implementation ideas with them. We couldn't have done this work without their support. Referee includes a Canary configuration generator tool to enable teams to build their Canary config. A lot of this is based off of the user experience that is in the Spinnaker Deck UI. As you can see in this Canary config, some of the golden signals of latency and error counts are used as metrics to indicate the health of the service. Then there is the retrospective analysis tool. We built this tool to enable teams to rapidly iterate on their Canary configs. Retrospective analysis is a way to conduct Canary analysis on historical events or data. It can be used to speed up testing, So when users test small changes in their config, they don't have to wait for a full Canary run every time. In this example, we can see the scope is two different server groups. One is the baseline, and the other one is the Canary. Then we built a report viewer for our users to see their Canary results. In this example, we can tell from the green along the left-hand side of the screen that the Canary passed and all the metrics look healthy. Finally, we also have an internal documentation site in Referee, so you can host docs specific to your organization in the same place as the other existing tools. In addition to this custom Kayenta user interface, we made some contributions to Kayenta itself that Justin will walk you through.
So our engineering teams use signal effects to monitor and report those golden signals we talked about earlier. So when we first started, Kayenta didn't have signal effects support, so we added that. We also added signal effects support in Deck, Spinnaker's UI, so that the open source community can use signal effects as well. And then lastly, we added signal effects support to Halyard, the CLI for managing Spinnaker, so that the community can configure signal effects when managing their Spinnaker instances. Our engineering teams also use New Relic, and it was on our list of metric sources to contribute upstream. So when we saw that the community opened a PR for the initial integration of New Relic, we hopped on that PR to help review it, and we contributed some additional features to that user experience in Kayenta. And then we did our initial Canary research with Spinnaker, and we liked the user experience that automated Canary analysis stage offered. That stage is a user experience that is spread across multiple microservices. So we created a new endpoint in Kayenta that consolidates that user experience into a single API endpoint that users can call. So if you recall our phase 2 process chart for how Canary deployments work with Kayenta, Kayenta's endpoint originally just had an endpoint that enables the fetch and judge portion of phase 2. And then the rest of that phase 2 logic was in another microservice called Orca that gets triggered via Spinnaker pipelines. But then with the new standalone endpoint, you can do that aggregated analysis over multiple iterations just using the Kayenta API. We had originally implemented this as an internal Kayenta plugin, but we noticed a lot of people on the Spinnaker Slack and in GitHub asking how they could do this. So we made a PR and contributed it as an official endpoint in Kayenta. So this covers our open source contributions for the most part, and Melana's gonna walk you through what you have to build to integrate all of this in practice.
Using Kayenta is not as simple as just making an API call. If you are using Spinnaker to Canary, there's a lot of integration work built in for you to use. However, if you're using standalone Kayenta, there are some technical challenges that you will have to figure out on the enterprise level. To use standalone Kayenta, you will have to stand up infrastructure to orchestrate Canary deployments shown here by the phase 1 diagram. At Nike, we made a pipeline that stands up the infrastructure, calls and pulls the standalone endpoint, and then generates a report from the Canary results. After the Canary judgment has been made, if the Canary passed, we want it to be deployed to production, and if the Canary failed, we want it to be rolled back. So we also orchestrated the process for promotions and rollbacks. We made manual and automatic modes for the promotions and rollbacks to enable our users to do what works for them. In automatic mode, the Canary will be automatically promoted if it passed and rolled back if it failed. In manual mode, the user will be prompted to make a final decision and determine that promotion or rollback, regardless of whether the Canary passed or failed. You will also have to update your foundation metrics configuration so it reports server group and location metadata. At Nike, we additionally wired up notifications so that users are notified when their Canary is complete. We did this by implementing an event listener in a custom Kayenta plugin. To recap, this is what is available for you to use: standalone Kayenta, Referee, and metric source integrations. And this is what you will have to build. You have to set up your orchestration process, which is phase 1. You will have to update your metrics configuration, and optionally, you can wire up notifications. We've moved through theory and implementation. Now experience. What will canarying with Standalone Kayenta actually look like for your engineers? Let's just show you our own example. So working on canarying and referee isn't actually Justin and I's day job. We work on another product called Cerberus, an open source secure property store for cloud applications. Shameless plug, check us out. We wanted to use canary analysis with Cerberus, so while we were developing the whole process of Standalone Kayenta with referee, we were actually wiring it up the whole time with Cerberus. So we currently use our entire canary analysis process in production with Cerberus. So what did we do in order to canary? We had to instrument our metrics, integrate into our pipelines, create our canary config and test it, and then we were able to run canary deployments. So we had canary deployments working for a couple of months. But then one day we got a Slack notification. Our canary failed. And we were confused because we had made a fairly innocuous code change. Now, if this is starting to sound familiar, you are absolutely correct. This is the exact same situation that we outlined in the beginning of the presentation, because it actually happened to us. But this time, we had canary. So we clicked on the report and we investigated the failed canary. The canary appeared to have a memory leak, as we can see here from this graph on memory usage, where the canary is represented by the orange line spiking across your screen. So we thought our memory was going out of control, but we had no idea why. The code change we made was minor, and it shouldn't have affected memory. We rebaked a new AMI with what was last working in production, and we did another canary deployment, expecting the canary to pass, because this was being done on code that had already been working in production. But the canary failed again. What was going on? We hypothesized that something external had changed. So we worked with our foundational infrastructure team to do a root cause analysis. After digging deeper, we realized that a middleware agent on the system had had a security update. So our team rolled that change back, and we baked a new AMI with the old agent, but the new code. We reran the canary, and the canary passed, so we finally could deploy. Canarying prevented a potential production outage. Because we used Standalone Kayenta and referee, this change never fully went out to production, and we avoided a large-scale memory leak. Many teams use Cerberus, and if we have an outage, that has ripple effects for all of the services that depend on us. This was our story, but it could be yours. Make your life easier as a developer. Spend less time manually watching graphs and logs. Prevent large-scale production issues. Canary. Justin is going to walk you through how you can get started today.
All right, so what can you do today? You can start canarying today with Spinnaker because it has first-class features right out of the box. If you want to use Standalone Kayenta, we've documented a lot of what we discussed today with more technical details as markdown documentation in the Kayenta project itself. Check out the referee project if you're interested in a UI that was made just for Kayenta. And then join us on the Kayenta channel in the Spinnaker Slack. We're very active there, and I'm constantly interacting with people that have questions. Feel free to email us. And if you liked our story, Nike's always looking for good engineers. Here are some of the materials that we found useful during our journey. These are all clickable links, and and the deck should be available online. Email us or reach out to us in Slack if it's not. All right, thank you. And then who has the first question?
So for those of you who also came, we want to let you know that in the back we have stickers of all the logos that you saw today. So on your way out, please feel free to take some stickers of referee and Cerberus. You had a question?
Yeah, sir.
Yeah, we stole it because there's two of us.
I'm curious, when you're picking metrics to use to decide whether things are good, if we're in microservices land and we're testing some service way down at the bottom and it could be fine, sort of breaks things in other places, do you kind of have a thing where you always look at some top level metrics of the whole system, or are you looking at individual microservices?
So in our personal example of Cerberus, we are just looking at metrics related to Cerberus. But let's take, I was thinking about this actually earlier, so let's take Spinnaker as an example. So it's a system that's composed of many microservices. So one of the cool things that Kayenta supports is inline templates. So and that's just basically the ability to write whatever query to find whatever metric you want. So you could potentially utilize that and be like, has the number of successful deploys decreased or increased? And then you could look at that, like let's say you made a change to one of Spinnaker's microservices. You could potentially use that as a metric. I haven't done that in practice, so I can't like officially speak about it.
You mentioned using retrospective data and releases to help you fine-tune Canary configurations. Do you mind just diving into a little bit about how that works?
Sorry.
Yeah, no problem. So
we have another.
Kayenta API allows you to put through a Canary analysis request where you can put timestamps that happened in the past. So it's really awesome because, like we had said in the presentation, you can make modifications to your Canary config and you can keep testing it on the same set of data and you can iterate really quickly. And what's also cool about retrospective analysis is that if something did go wrong in your service, you can keep using that historical event as a case study for yourself. Okay, we know we went through that failure. We want to do better next time. Are the changes that we've made to our system since then, would they have alerted us of that problem? So you can use important, crucial events in your own software's timeline, and you're able to check back in.
And maybe another example, I'm not sure if you just said this, maybe I'm saying it in a different way, but let's say you had a Canary and it passed, but then there was a production issue. So obviously your Canary config wasn't up to snuff, so you can then now use that historical data and do retrospective analysis and tweak that config until it fails, where it would have failed, and that's prevented that from going on to production. Another really cool thing that some of the teams in Nigeria is they're using retrospective analysis to sort of like judge a performance testing. So they'll like run a performance test and then they'll run it again with the same parameters but with tweaks. And then you can like retrospectively analyze that with shifting time windows. So they were running at the same time, but you're still doing the A/B style statistical comparison.
Could you talk more about the standalone Kayenta, how you have decided how to run? So did you take out Kayenta from Spinnaker and run it as a standalone service, or do you just expose the standalone API as part of Spinnaker and have your own Spinnaker instance there?
Yeah, sure. So we just took open source Spinnaker as it is, and we just run that because it's, I mean, at the end of the day, it's a Spring Boot microservice. You can have it produce a fat jar, so we have an area that just runs it as a Java microservice on its own. So we didn't use, I used Halyard to initially create the initial Kayenta config, but then I just I have that config stored and I just launch that microservice and then we use its API.
One behind you in the back.
Hi, so my question is, can Canary analysis help you find problems that only arise when the service is receiving a high amount of traffic? So perhaps when production is receiving 100% traffic, then you'll see the problem, but in Canary you'll only see 3% or 1%, you won't experience the same problem. So is there something that Nike does or other companies do to handle that?
Yeah, I can speak to it a little bit, and I'm not sure, maybe Chris Sannon's gonna scold me, but we use synthetic traffic. So there's this project, it's open source, it's called Gatling. So we actually have a bunch of scenarios written that simulate our users. So in our test environment, it doesn't get a lot of traffic, but we still like Canary there. So while the Canary analysis is running, parallel, we're injecting a bunch of synthetic traffic. And that was actually a lesson learned, because the thing we showed you earlier, the Canary only failed in production. It didn't fail in test. And then, so when we went back and did the synthetic traffic, we were able to reproduce the memory leak. So synthetic traffic is our answer. Maybe other people have other answers.
And you had asked, questions about how to operate your Canary, and that goes back to what Justin started the theory section off with, which was defining what is healthy for your service. And with Canary, it's very important to understand your service. So your comment on when you get 3% or when you get 100% of your traffic, all of that, sometimes it can be institutional knowledge about your service that you have from just working on it should influence how you set up your Canary. And thinking through when you're gonna get hit with peak traffic, using synthetic traffic is one way to be able to simulate that peak traffic. And also maybe if it's patterned, you can make sure that you run your Canary when you're getting that peak traffic and be conscious of that.
I think another valid pattern that people use is they just run the Canaries a lot longer. So then problems will crop up over a longer period of time.
Do you ever see application teams scaling the number of nodes that go to the Canary during the Canary test?
As of right now, because we're on a centralized team and we have curated pipelines, we don't really allow, they're declarative, so the engineering teams don't really have hooks into that kind of stuff. So we make them say how many instances they want for their experiment in their declarative, DSL, and then that's it. Because I know there's always, it's been brought up in our COPs, which are internal meetups. People want to go from 1% to 100% over time, and so we're not doing that as of today.
Okay. Do you have a view that that's a bad idea, or you're just not there yet?
I think it's a complicated idea. So like a slide we talk about coarse grain routing, that's really, really easy to implement in size-based. So it's also really easy to implement this other thing. And then the question you gotta ask or that I ask myself is adding that extra complexity, does it actually add value? Or is it good enough just to do one instance of each? Are you gonna get, what's the ROI on all that extra complicated logic?
So you mentioned that referee was for people that couldn't adopt Spinnaker completely, right? So my question is, why has Nike not been able to adopt Spinnaker 100%? And what are the obstacles you guys have? And I think a lot of people here would like to learn from that and try to use your experiences when you adopting Spinnaker completely.
Right, so I think first for any company or organization, they need to choose to use the technology and deployment processes that work for them at particular times and times in that company's evolution in CI/CD and DevOps and best practices. So at the time when we were considering Spinnaker, we also had some other options that were more built in and ingrained into how Nike's architecture was working, and we decided to commit to that path. And our case study on creating and enabling Kayenta to be standalone, we're really excited that that was something that came out of us not using Spinnaker, because with the aid of the Spinnaker and Kayenta open source community, we've proven that these microservices and Spinnaker certainly add value in that ecosystem of microservices, but they also add value individually as their own components and as their own tools. So for teams who are working through their own CI/CD decision-making process, I think that you can find value in so many different parts of Spinnaker, and leaning in and collaborating to make those technical components work for where your team is at and the requirements that you have, you can add a lot of value to the rest of the community.
Yeah, I just want to add to that. So the reason we're not using Spinnaker today is not because it's not a good product. It's mostly about the fact that we were already, like, I'm just going to make up a number, 50% into transitioning to our next generation platform that we had already written. So we already had a next generation platform that it's extremely declarative, and we decided we wanted everything as code. We didn't want users to have a UI where they can manually manipulate infrastructure, and we were already halfway through transitioning to that. Our leadership was like, we don't want to pivot again, we're already in the middle of a pivot. So maybe in the future we'll use Spinnaker, but we don't know for sure.